Hi, my name is Matou Kouhi. I am Associate Professor at College of Engineering in the Department of Architectural Engineering. Today we will introduce our lab 1008, which is situated and located in building E5, dealing with natural lighting. You are welcome. So basically this laboratory is dealing with daylight, and we are introducing to the student, both undergrad and grad student, the interaction of the natural lighting with their design buildings, which is really an important issue that should be taken into account when they are designing any component or the whole project of their architectural design. Therefore, they have to take into account how to take from this free energy, free lighting coming from outside, how they will introduce this light inside their building, but also in correct way. So we will show you some equipment. First, we have some about safety. Okay, we have the fire extinguisher, and also we have those powder and also CO2 extinguishers. Also within the COVID, as you know, we have some items here that should be always considered by our students and also our staff. So now we will start some explanation about two main devices that are used by our student. The first one is what we call the model Heliodon, basically used for by our undergrad student. So this system will allow students to understand the interaction between the lighting, the free or what we call the daylight within their buildings, how to bring this light inside their building. And then we have another more advanced system that will be explained later on. So I think that we will start some explanation about this device. Okay, so as you can see, it's a very advanced system, okay, for adjusting the angle between flat surface and the beam of the light. So here we have to adjust some parameters first. You know that the first one is the location of our building. So we have to see the latitude. Therefore, this latitude is adjusted by choosing the appropriate angle that you can see here. For example, in case of Al Ain here in UAE, it's around 23. Therefore, we will just adjust this latitude. Here we can also choose different seasons. So we have different months, okay, during the whole year, because as you know, the daylight changes also during the day and also during the year. Therefore, we have different seasons. For example, if I start running the device, we have different seasons. Here we have January, then we have February, you can see, okay. So here, those lamps, they are simulating the sun. They are simulating the sun. So different, if we choose, for example, let's say June, okay. And then during June, also we can adjust the timing, okay, at different timing during the day from the sunrise to the sunset. Also we can have the exact position of the sun that will send this kind of energy or light. Then we will see how it will interact with the building. Okay, so the main, as I said, the main target of this device is to allow our undergrad student to understand how to design their building and especially how to design their openings. Okay, because mainly the daylight will penetrate through the window or any opening. Therefore, the size of the opening and also the location of this opening, if we choose another building, as you can see here, this one is much bigger. What would be the impact of the size of this light coming from the sun to enter the building? So this is the main target of this device. Also we can study the orientation of our building. So it could be, for example, here we have towards the south direction, as you can see, and then we may have our building also facing the west So how it will impact? How it will impact at this position of the sun during the day? As you can see here, there is almost nothing coming inside. But if the building is oriented towards the west, as you can see, or the east, we have a huge amount of energy coming from the sun that will penetrate inside the building. So those are basically, of course, this system doesn't really simulate the real condition of the sky because it's just okay for teaching purpose. Therefore, we have another more advanced system, which is the sky, the artificial sky that we have inside that we will explain right now. This will allow students to understand the real condition of the sky, okay, from the clear sky to cloudy sky, and then of course in between. So here we can just have a very short demonstration of this. If we want to, for example, assess the amount of the daylight, let's say at noon, this is the noon, as you can see here, noon, 1, 2, 3, those are the timing, okay? And then we have this equipment is called the light meter, okay? It allows us to measure the level of the lighting given in lux. Lux is the unit of this parameter. So as you can see here, if I want to measure this, just make it on and adjusting the range because it has to be adjusted also. So here we have this given in lux. The range, this is given in kilolux, okay? So here we have this kind around 1,000, okay, or around 100 lux at this position. But what happens if we have another position of the sun? It will change, okay? As you can see here, it will change. It's around 200 to 300. Again, if we change the position of the building, we will see that we will get more amount of daylight. So here we can have even 700 around 600, okay? It's not really stable, but it's much more than it used to be before. So all those kind of information will allow our student to understand how to build a building and how it will interact with the sun, because again our target is to bring this free energy. We want to use daylight during, of course, daytime, instead to use artificial lighting, which is of course expensive and also needs more equipment and more advanced technology. So this is basically what we have here for this, what we call the model 126 Heliodon. Okay, it's basically for instruction and teaching purpose. Now, as I said, we have another more advanced equipment, which is the same but with more advanced features, what we call the artificial sky. So this artificial sky, we have only 2 similar devices in the whole region. So this has been purchased a couple of years ago by Professor Khalid Salal, who left this university just last year. So basically this system is really advanced one, and the comparison between this system and the previous one is that this one simulates really the real condition of the sky, okay? Because sky could be cloudy or partially cloudy or clear. So in this is what we call the full dome artificial sky, okay? So used by universities and laboratories and mainly for research targets, okay? So here we have different lamps, LED lamps, okay, very advanced also technology, with an amount of 1,200 watt or 1.2 kilowatt, which is almost the amount of the sun radiation coming from the sun, because the sun has 2 main component, we have the direct light and we have the diffuse light. So all those parameters are really adjusted here. That cannot be done with the first device. So this allows to work on the scale model. Of course, we will have all the lighting coming here. And then the point here is that we can adjust the real condition of the sky. So is it 80% clear, 60% clear, 40% clear, and so on. Also, the control is done from a PC, okay, using advanced also and specialized software. Then we can introduce all the parameters inside, okay, adjusting the building form, adjusting the location, okay, the condition of the sky, and then we can evaluate the natural light that we have, sun screening, and also the most important thing is the shadow. If you have different buildings, okay, how the interaction or how one building may affect the second one in terms of shadow, and also evaluating the solar gain, the shadings, and so on. So this is really very, very advanced and very, very expensive system. As I said, we have maybe in this region only two. I think one in Saudi Arabia and one here. So therefore, those are basically intended for research purpose. Okay, but also we can show for some students such kind of systems, how we can include them in our teaching process, okay, to allow them to understand the whole picture of the daylight and the importance of the daylight for architect engineers. Thank you very much.